Okay, so we're practicing graphing tangent. So again, I always do this so that I can kind of see what's going on. So k plus a tangent bx minus h. Okay, so let's see. Amplitude, center line, period. So let's see. This is my k, which is my center line. So y equals 1. So it's been shifted up 1. My amplitude is 2. So I have a vertical stretch by 2. I have no change in period, so my period is 2 pi, but I do have a shift. So my shift is left 3 pi over 2. Okay? So here we go. So let's start by drawing our parent function for tangent. So again, our parent function for tangent, pi over 2, 3 pi over 2 are my asymptotes. 0 is at 0, pi, 2 pi, positive 1, negative 1, positive 1, negative 1. So again, think of it, these are as quadrants. From 0 to pi over 2 is quadrant 1, where tangent is positive, pi over 2 to pi, quadrant 2, quadrant 3 positive, quadrant 4 negative. So it kind of makes sense. Okay? So here we go. Let's look at my information. Well, I know my center line has been moved up here to 1. I know my vertical shift, my vertical stretch is by 2. So it's going to be up here and 1, 2 down there. I know I've been shifted to the left 3 pi over 2, which means that tangent's going to start here, and since my period is 2 pi, it's going to end here. Okay? So before I even get started, I know that that's going to happen. So I keep telling you guys, you should always start with your stretches and compressions, either horizontal, which we don't have because there's no change in period, or my vertical, which is my vertical stretch. So my new 0 here, here, and here don't change, but this point has been stretched to 2, negative 2, positive 2, negative 2. So here is my vertical stretch. So that's that. And then I'm going to do my shifts at the same time. So all of these, this is going to go here, up 1. This one here, oh, let's do the asymptotes. So the asymptote here is going to end up right there. And 3 pi over 2 is going to end up at 0. And then this 0 is going to be here. And this 0 is going to end up right there. And then this one's going to go up 1 and then over to here. And this one is going to go up 1 over to here. And then here and there. And did my function end up where I thought it was? Well, let's look at this box. There you go. Now, if I was doing just the box method, okay, like I wasn't going to go through each individual transformation, okay, so I'm going to get rid of all of this, and I'm just going to focus on the idea of using this box to graph my trig function. Center line's still at 1, amplitude's 2, so there's my amplitude up 2, there's my amplitude down 2, then my beginning, which is starting at 3 pi over 2 and ending at pi over 2. So it begins here, ends there. Okay? Then I'm going to graph sine's major points. So sine starts at a 0 ends on a 0, middle is 0, in the middle it's at its maximum, in the middle of here it's at its minimum. So this is going to help me graph my tangent, because tangent has the same zeros. So where sine has zeros, tangent has zeros. Where tangent has its maximum or its minimum, that's where tangent's asymptotes are. And then this point, that's there, this point's there on the box, this point's there at the box, and then this point is there at the box. And look, it gives me the same function if I did it the other way.